Well, I can't believe I actually have to use my recording device here, my LG V30 in widescreen mode in order to pick all this stuff up. But it's over such a long path with the hoses stretched out. It's the only way I can really show everything all in one shot very easily. So let me switch back to standard angle and let's take a look at these machines. So what we have here is a 2008 Centria 1 over in the left. That's that nifty little orange machine. And then the one in the middle is a Centria 2. That's from 2013. And the one over in the right is an Avalier 1, and that was graciously donated by Alan O. So these machines now, at this point in time, have completely gone through my refurbishment and polish process, such as it is, and they have their original hoses. They're all plugged into the same power strip, and I have done some very exhaustive and extensive airflow tests. So for those who are unfamiliar with that weird black long tube, that's a Baird airflow meter, and that gives you some pretty accurate results, but it's only within a certain range. And then, of course, I've got a GM 8901 anemometer, very inexpensive, very, very good, precise device if you are familiar with how to use it. And I have some formalized airflow measurements with that. But I also took my power gauge and I measured the power at the same time I was trying to get the CFM. Now remember, this is only comparing the high speed capabilities of these Kirbys converted with their outer bags obviously munched like that. And I used the exact same test bag. I've got a single red Avalier test bag. Well, it came out when the Avalier came out. The one with the red printing on it, and I used it for all three machines one at a time. So very, very consistent results. But what I want to find out is, we all know that these particular machines have tremendous amount of airflow at the end of the hose, but it's not the same airflow. And also, these machines are technically all rated at 7 amps. Of course, I mean, Kirby doesn't really specify, well, is that 7 amps, say with the power nozzle, with the brush roll spinning, is that 7 amps with the hose attached? It just says, it's just 7 amps. So this is really an efficiency test. That's really the point of this video. So one of these machines has notably higher airflow than the other two. And one of them has notably lower airflow than the other two. But what are their efficiencies? In other words, if we take the amount of power that's being consumed as measured by this little device, and we standardized everything at 121 volts. I was able to make sure that we had a nice standard 121 volts. How much power, how many watts does each one of these things use to produce a single CFM? You might be surprised at the results. So just for demonstration purposes, I'll go ahead and use the Baird meter because I don't really show that a whole lot anymore. Let's start off with the Centria 1. So definitely smacks the 10, and the 10 here is 110 CFM. So if it smacks it, it's something beyond 110 CFM. Okay, now let's go on to the Centria 2. So Centria 2 appears to smack that 10 with a little more force than the Centria 1. Okay, let's go to the Avalier. as you saw, the Avalier still was able to go and pretty much max out to that 10, but it wasn't as forceful as the Centria 2. Ooh, maybe that means something. And now it's time for the formalized results. Starting with the Centria 1 on the left, I got 114.1 CFM out of the hose at 6.04 amp current draw, which means that's 731 watts. So if you take 731 watts, divide that by 114 CFM, I'm just going to do three significant figures here, we have an efficiency rating of 6.41 watts per CFM. Moving on to the middle machine, the Centria 2, I pulled a whopping 119.2 CFM. Now that's at 121 volts using 6.80 amps. And that corresponds to 823 watts. If I take 823 watts and I divide that by 119 CFM, I get an efficiency of 6.92 watts per CFM. Okay, lastly, over on the right, the Avalier, I pulled 109.4 CFM. That's right, the lowest of that triplet. But I was using 6.26 amps, again at 121 volts, for a total power draw of 757 watts. If I take 757 watts and I divide that by 109 CFM, I get 6.94 watts per CFM. So if you compare the Centria 2 and the Avalier, the efficiency ratings, 6.92 for the Centria 2 versus 6.94 for the Avalier, that's essentially a wash. That's the same. But the Centria 2, the motor itself, is actually scaled up. So it's about 10% more powerful. Now, when I was taking apart the Centria 2, I noticed a date code on the motor, and I was able to verify that the motor was made in 2013. Now, for whatever reason, maybe they were having a good day. Maybe they put some extra coil windings in there. Maybe they had better materials that day. Whatever. It is about 10% more powerful than an Avalier, and it's even more powerful than that when you compare it to a Centria 1. So I found that fascinating. And when I got this machine at a thrift store in the summer of 2016, I knew immediately that I had a machine that was definitely different over my G6, but I had suspected that maybe, just maybe, it was even a little better than either a machine a little older than it, say a Centria 1, or a machine a little bit newer than it, say an Avalier 1. Now, I don't know what an Avalier 2 will actually do. I don't have one here to test, but I thought that was interesting. So to sum this up, the Centria 1 is the most efficient per each CFM generated at 6.41 watts per CFM. And the least efficient, only by a tiny bit, insignificant, is the Avalier at 6.94 watts per CFM. So the Centria 2 and the Avalier are essentially similar machines running on high speed, but the Centria 2 has almost about an extra 10% power boost, right in that range. So that's kind of interesting. And again, I'm just comparing this in hose mode on high speed. It won't be necessarily the same thing running on lower speed using the nozzles. But I don't think that These three represent the best hose efficiencies that I have. Let me see if I can come up with another machine that has a better hose CFM efficiency. Here I have a 1988 Heritage 2 Legend, and if you remember in some previous videos, I have gone and completely refurbished it. So we have a new A-modal fan, new front and rear bearing, all the fancy little grease, polished the commutator, blah, 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 we're all ready to go. Same red Kirby HEPA bag, but you'll notice there is one difference. I've got two hoses right here, and one's a little more appropriate than the other one. So this is normally what you're used to seeing with Heritage 2 Legends, the one with the plastic end here. However, this one is a little too leaky to use for the tests. This one here is older, and it's got metal ends, metal crimp, and it does actually quite a bit better with airflow. I think it's like 7 or 8 CFM better. So I made the command decision to use the better hose, even though they're, you know, older heritage style hoses. This one is a newer one, and then this one is an older one, and this older one in this case is less beat up, so it gives a better result. So for the formal and informal tests, this is actually what I'm going to use. So let me go and change the camera angle, and let's take a look and see what the Baird meter reads. So this over 30-year-old machine with an even older hose practically pulls a 9. And a 9, turn around, is a 6. And this 9 would represent 108 CFM. So that's not bad for a machine that supposedly has a motor that when you hook the hose up is rated at 5.5 amps. So let's go and sum all this up. Try as I must, when I crunch the numbers, the Heritage 2 Legend, in the end, did not win the efficiency competition, but it was real close. Coming in at 106.4 CFM from the hose and using only 5.7 amps, totaling 690 watts, this Heritage 2 Legend did 6.51 watts per CFM created. So real close, but it didn't actually beat the most efficient machine I have here shown in this forkball, which is dun, da, 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 the Centria 1, the one with the orange trim there, coming in at 114 CFM and a efficiency rating of 6.41 watts per CFM. The Centria 1 actually wins the overall efficiency game, but the most powerful machine, using the most power and giving the most CFM, is right next to it, the Centria 2, 119 CFM, but also using the most power at 823 watts. So I guess what I'd like to ask the YouTube community is, how many of you know of any machines that can pull CFM numbers like this at the end of the hose and use 800 or maybe even 700 watts? Be very, very green about it and still pull 100, 110, maybe even close to 120. Really fantastic. I think there might be some central vacuums or maybe some other rigs out there that can pull maybe 110 or 120 at the hose, but I bet they use 16, 17, 1800 watts or more. So in any case, I think what a lot of people might not realize is these machines are great for converted above the floor cleaning. I think a lot of people, even Kirby owners, forget that if you hook up a hose, you have an awful lot of tools to choose from. You can do all different kinds of things, and you have a tremendous amount of usable airflow, and it doesn't use a whole lot of electricity. So I guess if all we can get out of this video is, hey, hook up your hose and use your tools once in a while if that really makes a whole lot of sense to you, because you should probably have a pretty decent above the floor cleaning experience. You don't always have to just leave your Kirby in upright mode. You can convert it and you'll still have an awful lot of power. For the most part, very comparable to the top of the line canisters, and also, and this can be shocking for a lot of people, also central vacuum systems. So thanks for watching. Stay tuned for more.